Hi, grade 12. Let's look at this problem, which is the same as the questions that we worked on previously. So the questions are the same. Let's look at what we need to do on this one. So now they say that a ball A is thrown vertically up from the button foot, from the bottom foot of a building which is 8 meters high, and the initial velocity of ball A is 15 meters per second. So they tell you that after 0.5 seconds, ball B is also thrown vertically upward from the top of the building. Both balls reach a maximum height at point P at the same time. So now let's answer the following question. I need you to consult your exam guideline. We won't waste time defining projectile motion. Let's work on 4.2.1. They want us to find the time taken for ball A to return to the ground. Remember on the previous question paper, on the previous lesson that we worked on, they wanted you to find the time that it will take ball A to reach maximum height. But this time they want to know the time it will take ball A to return to the ground. So we need to find the time ball A travels through this displacement. The time that we get, we multiply it by 2, because remember the time that ball A will take to reach its maximum height, it will come back to the ground with the same time. So the answer that we get, we need to multiply it by 2. Let's quickly work on that. 4.2.1, we can start with data. So let's take up as positive. So when we take up as positive, we're going to say, okay, we know that this will reach its maximum height. So the V final is 0 meters per second, and the V initial is given as 15 meters per second. So we say up as positive. So why are we using the maximum height? We need to know the time it takes ball A to reach its maximum height. Then the time it moves from the ground to the maximum height is the time that it will come back to the ground. It's the same time. So now, from this information, I'm going to say my acceleration, this thing is moving where? It's moving up. The acceleration always goes down, and we set up as positive. This will make the acceleration to be negative. We are looking for delta t. So we're going to use the equation that doesn't have delta y. So to find this, we're going to say this is V final, it's equals to V initial plus A delta t. Let's do the substitution. My final velocity is 0. My V initial is given as 15 plus into negative 9.8 delta t. Okay, let's move the 15 this side to be negative 15. Equate this to negative 9.8 delta t. Divide both sides by negative 9.8. What is your delta t equals to? So we're saying negative 15. We need to divide that by negative 9.8. So on my side, I got my time to be 1.53. So this is 1.53 seconds. Remember, this is the time it takes to move from, this ball A from this point to that point, which will be the same time it will come back to the ground. So we need to take this time, multiply it by 2. Therefore, the delta t total, it's equal to 1.53 seconds multiplied by 2. This gives us 3.06 seconds. So the time that it will take the ball to return to the ground is 3.06. 4.2.2, they want us to find the speed at which ball B is thrown upwards. So now remember, ball B will also have a final velocity at maximum of 0 meters per second. So to answer this 4.2.2, we need to do data. Right. So the V final of that one is 0. The V final will be 0 meters per second. Then we are looking for the initial velocity. The acceleration is negative 9.8 meters per second. Okay, so now what else do we know? We're going to use, okay, so this is what we have so far. We can substitute everything, but now let's talk about the time. What is delta t? The time that it will take ball B to reach its maximum height. Look at the statement. Both balls will reach the maximum height at point P at the same time. Remember on the previous lesson, we said since they're going to reach at the same time, we're going to take this time, the time that it will take ball A to reach its maximum height, then we subtract the 0.5 seconds because they're going to reach the maximum height at the same time. So delta t will be 1.53. You're going to take the 1.53, you subtract 0.5 seconds. I hope this makes sense. So delta t for ball B, it's going to be 1.03 seconds. So this tells us that for B, it will reach the maximum height after 1.03 seconds. So to find the V initial, we're going to use the following formula. We're going to say this is Vf, it's equals to V initial plus A delta t. So the final velocity is 0 and the initial velocity is what we are looking for. Then we're going to say plus into negative 9.8 delta t of what? 1.03 seconds. Right, so what is negative 9.8? We need to take the negative 9.8, multiply that with 1.03, and we get this to be 10 point something. This is V initial plus, okay, let's just put this to be negative. Minus 10.094 is equal to 0. So we can conclude and say the V initial of B is going to be 10.094 meters per second. Then we've answered that question, is going up. Right. So let's answer the last question, which is 4.3.2. If you still remember, these are the same questions that we did on the previous question. Now they want the height of the building. So remember, we said that to find this height, we need to find the height traveled by ball A. Then, I'm sorry, we subtract the height traveled by ball B to find H. So I have this as point P. I have this as, this is point P. This is the rooftop, and this is the ground. So to find this height, we need to find the height traveled by A, then we subtract the height traveled by B. Then we're going to get that part. I hope this makes sense. Let's work on that. First thing first, you need to calculate the height traveled by what? Ball A. Let's work on that. Let's work on that. Let's find the height traveled by ball A. So I'm going to say for 4.2.3, let's find the height traveled by ball A. So we need to use the formula that has delta y. So this is V squared. It's equals to V initial squared plus 2a delta y. Let's substitute. The final velocity is the maximum height, which is 0. So this will be 0 it's equal to the initial velocity is that 15, so this will be 15 squared plus 2. Remember a is negative 9.8. We are looking for delta y. So now I'm going to say my 15 squared is just 225, which comes this side to be negative 225. It's equals to negative 19.6 delta y. Divide both sides by delta by 19.6. So this divided by negative 19.6, we get an answer of 11.48 meters. So delta y is 11.48 meters. This is the height traveled by what? This is the height traveled by ball A. We need to find the height traveled by ball B. So this is 4.2.3. We need the height traveled by ball B. Let's work on that. Let's work on that. So this will be V final squared. It's equal to V initial plus 2A delta y. So my V final is maximum, and V initial we're going to use the one that we got, which is the 10.094. Right, so this will be, remember that is squared, so it's going to be 10.094 squared plus 2 into negative 9.8, and we are looking for delta y. Okay, so now when I say 10.094, and this is squared, I get 101 point something. Just not, let us not round that because this will give us problems. So we can bring this side to be negative 10.094, which is squared. It's equal to negative 19.6 delta y. Divide both sides by that negative 19.6. So we're going to divide this by negative 19.6. What do we get? We get our delta y to be 5.198. So when we round it off, it's 5.20. So delta y is 5.20 meters. This is the height traveled by ball B. So remember, to find the final height, so the height is equal to the height traveled by ball A, which is 11.48. We're going to subtract that 5.20. The answer that you get is your height of the building, which is 6.28. So this will be 6.28. And that's it for this lesson. This is how you find the height that is traveled at the height of the building. I'm very sorry. That's how you find the height of the building. So the questions are the same. So the difference is that they change the initial velocity of ball A and the time that ball B was also thrown vertically upward. Right, and that's it for this lesson. This is how we answer the vertical projectile motion questions.